Welcome to my YouTube channel. Today I'm talking about stepwise regression in statistics. So I'm actually finding myself hitting on a bunch of controversial topics in statistics. And one of them is stepwise regression. Stepwise regression isn't the most favored. And it depends on the metric you are using for your stepwise regression, but a lot of people dislike stepwise regression. I actually use it all the time in my playing around with R programming. I will often use stepwise regression to fit a model. But many people are of the opinion that stepwise regression isn't the best way to fit a model. If you use p-value criterion, you overfit the model, and it's not really what you ought to do. And I think other people would articulate the grievances with stepwise regression a lot better than I would, because I actually like it. I use AIC and BIC criterion, and I do it quite often. But people have their opinions about it, and a lot of people, especially not in the social sciences, would not consider using stepwise regression. Okay, so what is stepwise regression? So in stepwise regression, you specify a model with all your variables. So if you have one outcome and 30 possible predictive variables, you put them all into a model. And this is actually for R. I'm going to talk about it in the context of how you code it in R. So basically, you just specify a outcome and a set of candidate predictors that may or may not be related. You don't really know, and you don't necessarily care too much. You want to see if they are good predictors of your outcome, either alone or with a collection of other variables. And what stepwise regression will do is it will try all your variables over and over until it gets either a model with a bunch of significant results. If you're using p-value as your criterion, if you're using p-values less than 0.05, it will find a model with a bunch of significant p-values. And I believe that's what people don't like. They would argue that you should make a model based on subject matter expertise and knowledge, rather than using a model to define what's significant. And I could get behind that, but I don't actually use p-values as the criterion. I don't necessarily care that much. I don't care about that. Because, yeah, you'll get a bunch of significant things, and will that necessarily replicate? I don't know. Okay. But you can also use BIC and AIC, which I believe are better criterion. I believe I talk about BIC and AIC in a future video, so I'm not going to try to get too far into it, especially off the top of my head. But basically, they look at the likelihood of the model you made based on the data. Like how well does this model fit the data? BIC penalizes larger models more than AIC. So I actually tend to go towards BIC rather than AIC as my criterion. But I guess it really just depends on what you want. There's no right or wrong choice between AIC and BIC. Like I have said a few times in the series of controversial videos, I'm of the opinion that as long as you say what you did, the people who get mad about it can complain, but what are you going to really do? The only wrong thing is misleading people. Okay, so forward selection. You start with no predictions in the model, and the model adds variables one at a time, and if the p-value is significant, it keeps it. If the AIC decreases, I believe you want AIC and BIC to decrease, go more negative, then the variables are added. In backwards selection or backwards elimination, you start with all predictions in the model and you remove them one at a time. What I tend to do is the bidirectional or stepwise selection, where the model can do both. It can remove variables and it can add variables. And I feel that that's probably the most useful, for lack of a better word. It takes longer because you're not just going one direction. You can remove, add the same variable over and over. But it does converge. It's not a case that it would get stuck in an infinite loop of adding and removing variables. Okay, so I have a more detailed outline of what they do. So it starts with an empty model and it adds predictors. That's what forward selection does. Backward elimination, it starts with the full model and it removes predictors. And what I was saying earlier is that you still specify the full model in R, and that's just to tell R what predictor to even look at. So even in forward selection, you would still give it a full model just so it knows which variable to try to add. And bidirectional just goes in both directions. It's what I'd actually recommend, but that's really your choice. But I guess to even use this in general, your choice. To keep watching my video, it's your choice. Okay, anyway. So the advantage of stepwise regression is you can get a model with 1,000 predictors, and instead of manually trying to look at what fits the best, it will do it for you. You start running the stepwise regression, and you can walk away and come back, and then you'll have a decent model. And if you're doing some machine learning based tasks, I think that might actually be pretty good. If you're doing hypothesis testing, people would say, hey, maybe you shouldn't do that because you should do it based on theory rather than just throw a bunch of stuff out the wall and see what works. The concern is that it won't replicate. Or you'll overfit the noise. And it also depends on what metric you use. I think BIC and AIC favored over p-values, but I don't fully know the literature, especially the literature criticizing stepwise regression. The stepwise regression is definitely great in exploratory data analysis. I don't know that people have a problem with that. Just get a quick idea of what looks like it would be the most related to your outcome. I think what people might be upset about is doing a stepwise regression and making that your conclusion. And honestly, I'm speculating, so I like stepwise regression, and I haven't really read the critical literature. Okay, so yeah, that's the end of the video. If you have a bunch of predictors, try this, I guess.